Okay, so Radhe Radhe everyone. I'll be waiting for a little while before you guys before some of them join. What I'll do is till that time I'll just put it on Discord that I'm live. And someone just tell me that if I'm properly audible or not, okay? Because that is also a thing of concern for me. No response, okay? Like someone just tell me a hi or anything. Like if I can't see actually like how many people have joined or whether anyone has joined or not. Okay, it shows that there are two people watching this right now. Okay, so I'll just post the link of the Discord and Instagram. I'll just start with it. Okay, start with the video. Okay, so this is the post. This is the link to my Insta and Discord. If you have any doubt, and I'm audible, right? Okay, so this is the post. This is the link to my Insta and Discord. If you have any doubt, and I'm audible, right? Yeah, I'm properly audible, right? Okay, so let's start with today's problem. Find special substring, eat pizzas. This is okay. Okay, didn't get updated over here. Anyways, let's start. Find special substring of length k. Okay, you're given just a minute. Huh? Oh, okay. So if you guys can't comment anything over here, can't write in the live chat, it's because I have put on the subscribers only. I think the subscribers only stream. Okay, so you don't need to worry much about it. You can just subscribe my channel and then you will be able to type it down. Okay. Thank you for pointing it out. Dude, like someone just like write something so that I know that it's active or not because I don't know that whether it's active or not. No, I hope you're getting it, right? I'm not sure if I'm active or not. Okay, the first problem, find special substring of length k. You're given a string s and an integer k. Determine if there exists a substring of length exactly k in s such that it satisfies the following conditions. The substring consists of only one distinct character, example AAA, BBB, CCC, DDD. If there is a character immediately before the substring, it must be different from the character in the substring. If there is a character immediately after the substring, it must be also different from the character in the substring. Return true if such a substring exists, otherwise return false. You know what is a substring, I won't need to explain it. Okay, so let's go with an example. Okay, let's go with this example. I know you won't be able to see it actually, whatever I have written over here. Now I think it is visible, right? So whenever I'm doing a copy, so basically Leetcode gets copied up. So now see this, okay? Very interesting. So in this case, what we are going to do is we are going to find anything, okay, any substring of this which is of size 3, okay, which is of size 3. And one more thing that we have to check into it is that for that specific, that means that there are three consecutive characters in the string which are same, but the character just before it and just after is not the same if it exists. Okay, so there are two conditions where it satisfies. The first condition is this one, okay, this AAA, because the element just after this A, it is B, so it is satisfying. Similarly, this this AAA is also a satisfactory thing, okay, because the element just before it is B, and the element after it, there is no element after it. Okay, so basically there are two conditions where it satisfies. Now the condition, now what we have to do is we have to find this. How can we see that? How can we approach the problem, right? The problem approach is very simple. Since yesterday I was talking to you about the constants thing. See, s dot length is lesser than equal to 100, which means that we can have big O n cubed. We can go till big O n cubed, right? But obviously we won't need that. Big O n squared is more than enough, okay? But yeah, obviously you can go with something lesser than that also. What you can do is you can check out all the consecutive elements and try checking out all the consecutive elements, and if like there is a big O n approach to it also, okay? But since we are not that much concerned about it, because even the big O n approach is very simple and it is very much used, so I'll just go through the big O n squared approach, because yeah, we can get that complexity, right? It is okay. Am I lagging? Oh, okay, I was lagging a little bit. So see, what we can do is A. Okay, my handwriting sucks. A, B, A. Now what we can do for every specific element, let's say I'm at this position. So from that position, I have to find out if the next k elements are same or not. Okay, that means if k is equal to 3, if the next k minus 1 elements are same or not. That is, the next two elements are equal to this element or not. Okay, if it is equal, good, we are done with just the first step. Okay, just the first step. Next step, if the element before it exists and it is not equal to that or not. Okay, so obviously there is no element before it, so this also accepted. And what is the third step? If the element after it exists, yeah, there exists, and it is not equal to this element. Yes, B is not equal to this element, so this is also a valid thing. So only when all the three of them are valid, we can return it's a true. Otherwise we have to go on traversing throughout the whole array, and if at no position you find it is true, so you can return directly false. Okay, so see, I do for like the next k minus 1 elements, I check if any one of it is not equal to s of I, answer becomes false. If there is a previous element, that is, it is in the range of greater than equal to 0 and it is equal to s of I, answer is false. If there is a next element and it is equal to, answer is false. And if answer is true, that is, if all the three conditions satisfies, rather in this case I went for the complementary thing, that if none of the conditions satisfy, that means it's a true, right? So return true. And after going throughout the whole traversal, if there is no true at all, you can return false. Okay, is it clear? Can I move on to the next problem? Write in the comments, I mean in the live chat. Okay, just tell me one thing, like, are you guys being able to no, the Q&A. can you guys, I mean, not can you guys, are you guys being able to write in the live chat? Because I think if you're not able to write, you can go for yes or no. Okay, so if you can write, just press on yes, and if you can't, just press on no. No, okay. So just do one thing. If you're not being able to write, I'll just go through it. I'll just go through the live stream, this thing. Uh, See, I think there are 7 people, and there are 2 votes who are telling no. Just try one thing. Just try subscribing to my channel if you haven't subscribed yet, and then try to write. Okay, and tell me if it is still a no or not. Okay, I'll just put another poll. We are able to, yeah. So yeah, you guys are able to, right? Like yeah, if anyone is able to, so obviously everyone is able to. I'm not blocking anyone purposefully, right? So it's like you can just put a subscribe on my channel, and then you will be able to. Okay, I'll just put it out. If you are not able to write anything, just subscribe and write. Okay. Amit Muses. Are you into music, bro? Amit, bro. So like we can collab someday, jam someday. Okay, so let's. So I hope this is clear, right? A is clear, right? Should we move on to B? Not allowed. Just explore. Great. Should we move on to B? Is A is clear? Yes. Okay. Someone just wrote on yes and like removed it. Okay, it's yes, right? Great. Sure. Let's move on to B. See, B is eat pizzas. Okay. You're given an integer array pizzas of size n, where pizzas I of represent the weight of the ith pizza. Every day you eat exactly 4. I can't pronounce pizzas so many times. Okay. So let's say every time you eat exactly 4 array elements. Due to your incredible metabolism, you eat arrays of weight w, x, y, z, where z is the largest number and y is the second largest number. You can gain the weight of only one pizza. If it is an odd number day, you gain the weight of the z, that is the largest number. And on even number days, you gain the weight of the second largest number. Okay, the second largest one. You have to find the maximum total weight you can gain by eating all elements optimally. Okay, and it is guaranteed that n is a multiple of 4, so you don't need to check for it. And each element can be eaten only once. Okay, so let's take one example out of here. Okay, see, if the input is this, the output will be 14. Now how will the output be 14? I think if you are coming from the video that I uploaded, So it tells me that 2358 is a valid condition. So 2358, I can have 2358, okay, and then I can have 1, 4, 6, 7, right? So I can take the 8, that is the largest number on the, what was the condition? I can take the largest number on odd number days. So on the first day, I can take the largest number. On the second day, I can take the second largest number, right? So what is the approach that you should come up with to solve it, right? So if you notice one thing, we were trying to keep the largest two numbers, right? But we had to sacrifice 7. So what do I mean by that? So over here, there was a 7, there was a 8, right? So if we wanted to keep the largest two numbers, so it is not possible, right? That is somewhere where the whole thing breaks. So in that case, what we were about to do is we just removed the second largest number and put the value of the, I mean, we just, and put the value of the third largest number, right? Because, yeah, one of the largest we have to sacrifice, right? Now see one thing. So if you're sacrificing some of the largest numbers, so let's say we have to find out how many even number of days are going to be in that specific sequence, right? So let's say if there are X number of even days, so we have to sacrifice X large numbers, right? Now how can we do that, right? This is a question that would come to your mind, that how can we do that? So let's say there are total n number of days, among which X days are even, okay, and n minus X days are odd, right? So for the odd days, what we can do is, first of all, we can calculate for all the odd days, okay? So for all the n minus X days, we can find out from the array, after sorting it out, obviously, the the last n minus X elements, okay? And we know that since they are the odd days, so that consists of only the maximum elements. So you just do it. And for the next X even days, which means for an array of size X into 2, why X into 2? Because on the even days, we are going to ignore the largest number and we are going to consider the second largest number. So from this X into 2, what we have to do is, we have to take X numbers such that for every specific number that we are going to take, there is a number which is greater than that, right? That is what the condition tells us, and that is the most greediest approach that we can do. So over here, what we are going to do is, basically, there are two various steps that you can follow, okay? One step is, let's say you can divide the whole thing, okay? Like one is valid, other is not valid. So first let me tell you what is invalid, which may come to your mind. That is, first of all, take the whole X into 2 thing, then divide it into X and take this one, because every number over here is smaller than every number over here, right? So you're getting X pairs, right? But in that case, do you think that the sum of this is the maximum thing that you can take into consideration? Obviously not, right? Can you explain again why X into 2 and why and the thing not taking? Not taking. X into 2, okay, I'll just explain why X into 2. See, for the n minus X days, it was odd. It is good, okay? We know how to solve it. But for the X days, what we are going to do is the last part. Yeah, I get it. So for the X, I mean, I'll just explain it, the whole thing. So for the X days, there will be X, Y, Z. I think it was, sorry, it was not only X, Y, Z. It was W, X, Y, Z, I guess, right? Oh, not this one. Yeah, it was W, X, Y, Z, right? So it is going to be W, X, Y, Z, where we are going to consider the Y, right? But if we are going to consider the Y, it means that there will be a Z, right? There is a Z, which we are not going to consider. If we were considering the Z, there's a quiet delay in the chat. Yeah, I think that is because of the latency thing. Okay, Like I think just because I was streaming at a very high quality, so there is some delay in the chat. Yeah, but I think it's okay, right? Okay. So this z thing. So if we were considering the largest element, so in that case we didn't need to check what wxy is. We can take any value of wxy, right, from the beginning. But if we are going to consider the y, it means that there is a z. So in this case, how many elements are we considering? There are two elements that we are considering, right? That means for x, how many elements we will be considering? X into 2. And since we want to maximize it, so we have to consider the last x into 2 elements. Okay, so the last n minus x elements, it is going to be coming for the odd days, because I know that in those cases the last element is always going to be considered. So I will try to maximize it as much as possible. So the last n minus x I have done, and then for the next x into 2 I am doing. Okay, now since I was explaining in the previous part I was explaining the wrong concept, so now I will be explaining the correct concept. Okay, the correct concept is, in this x into 2, what you can do is you can find out every specific pair. Okay, so this pair, this pair, this pair, and for every pair you're going to consider the previous element. So we are going to very much be satisfied with the condition that we are having x pairs, okay, and there is one number in that pair that is greater than that. But or we could have done it like this also, which is the wrong approach. This is the correct approach, okay. Or we could have done it like this also, so that you know why it is the wrong approach. That is, we could have paired this element with this element, this element with this element, this element with this element. So in that case, we would be having this plus this plus this, right? Now see, in this case, in this previous case, you were considering this, and in this case also you're going to consider this, which is okay. In the previous case, you were considering this. In this case also, you're going to consider this. But in the previous case, you were considering this, okay? But over here, we are going to consider this. Now, obviously, this is lesser and this is greater. So this is a better approach. If you want the code, I can go walk you through the code quickly. Division is n by 4. That is how many days that we have to consider. And then I sort it out. And then I find out how many, like position is equal to n minus 1, even is equal to 0. What I basically do in this is I find out how many even number of days are there, okay, and till how much I have to move. Okay, since see over here I did a basic mathematical approach, I mean more of arithmetical approach, that I have to take out n minus x plus x into 2 elements, right, which means I need um, n plus x elements, right? Now if you want to find out what is the value of x, you can go for it. You can have it like n by 2 plus n mod 2, or maybe n by 2 only, okay, somewhat like that arithmetically. But since I saw that, yeah, we were given the we were given the freedom to have an array, so why would I do the arithmetic thing and instead not getting the code to do it, right? Because I have the ability to go till that time complexity, so I did it. So for all the days I considered, like if it is an even day, so I'm going to, sorry, if it is an odd day, so I will going to be considering only one element, and if it's an even day, I'm going to consider two elements, and even plus plus, that is the number of even days, okay. Now see, what we are going to do is, so yeah, position, you know that we have come down to the position. What is position? Position is this, okay. See, let me just explain it again for the position thing. Position is basically nothing but, let's say this is the n minus x elements, and this is the x into 2 elements, okay. This is the x into 2 elements, and this is n minus x elements. So this position, the first position of this, that is the position, okay, because we have to consider that only, right? Is it clear? Is it clear till now? Tell me. Okay, so let me just go through the remaining part of the code. So let's say int I is equal to position and I less than position plus even into 2. So I plus is equal to 2. So what I basically do is I go on like checking for all the, this is for the even days, okay? This is for the even days and this is for the odd days. So for the last n minus x elements, I just add the pizzas, and for the remaining, for the n for the x into 2 elements, I just put them into pairs and consider the element that is coming in the first part. Okay, so is it clear? Is it clear? This was which problem? B, right? Is B clear? I can add emotes over here. Is it like reacting to my own channel? Oh, it's like reacting to my own channel. Well, is it clear? Is it clear? Quickly tell me. No. Which part is not clear? What I did was counted all. Okay, someone wrote yes. Was counted all groups. Like whoever wrote no, which part is not clear? Okay. Then got how many odd days? Then added that much top elements. Then for even days, I added alternative elements for the remaining. Counted all groups. Then got how many odd days? Then added that much top elements. Right. For even days, I added alternative elements from the remaining. Yeah, that is exactly what I have done. That's good. And whoever wrote no, which was just not clear. Yeah, one more thing, like if you can't write it down over here, so I already mentioned that you have to like subscribe to my channel and then you will be able to write anything over here. Okay, I'll just check how much I'm lagging. I'll just check how much I'm lagging. Not that much, I guess. Okay, so if I don't get any like reason for the no, I'll just continue with the C. Okay, I'll wait for a little bit. Well, no response, so I'll move on to C. Okay, C is basically nothing but select k disjoint special substrings. Given a string S of length n and an integer k, determine whether it is possible to select k disjoint special substrings. What is a special substring? So before that, let me tell you what is disjoint. Strings, substrings which are not joined. That is, there is no overlap. Okay. What is overlap? So let's say if you're having a string like this. Okay. So if you're considering this substring and this substring, so both of them are disjoint because there is no joint between it. But if you're going to consider this and this substring, so there is a joint over here, right? This element is common, so that you can't take. So that is what you mean by disjoint. And what is a special substring? Let me just walk you through the definition first. Any character present inside the substring should not appear outside in the substring. Okay, outside in the string. The substring is not the entire string S. Okay, so what is a special substring? A special substring can't be this. That is the whole thing. It can't be the whole thing. And one more thing, the special substring means that, let's say if this is a special substring and this element doesn't occur anywhere over here or over here. Okay, and this element doesn't occur anywhere over here and over here. Clear? I know it will be it will seem a little bit of complex, whatever I explained about the definition of it. I think it will be better if I go with some test cases, right? Well, understood this much. Yeah, clear. So see, A B C D B A E F A B, right? So from this case, if you're going to take out K, right? So let me just make it a little bit bigger so for you to see. Okay, so I think this is good enough. See, now if you're going to consider this this D, okay, so you can notice one thing, that if I'm going to consider only this D, I mean this D, okay, only this D. So there is no other element outside that was tough but ranked 1 to 5 cheater. Don't know. So if you notice one thing, like for D, the remaining elements, there is no D in it, okay, for the remaining elements. And for E also, it is only present once. Even F is only present once, right? So if you're going to consider them individually, so let's say if I'm going to consider this D, only the D, so you can find out that there is no D outside it. So it is a valid substring. If you're going to consider this E, there is no E outside it. So it's a valid substring. If you're going to consider this F, there is no F outside it. So it's a valid substring. Clear? So there are 3 total substrings which are valid, and all of them are disjoint. Because yeah, if you're going to consider this D and E, right? Both are disjoint, and we got the this two substrings which are special, right? We got it, right? So it's a true, right? It's a true. But for this C, D, E, F, D, C and K is equal to 3, you can notice one thing, that E and F are the only things that is going to satisfy. So let me let's write it C, D, E, F, D, C, right? C, D, oh, C, D, E, F, D, C. Clear? This is a string, and you have to find out 3 disjoint substrings over here. So yeah, one of it is this E, one of it is F. But if you're going to consider this, so you can't consider this, right? Because C is over here and D is also over here. So both of them are over here. So you can't consider it. Now you may come up with a solution that, let's say if you're going to merge this whole D thing. So we know that D, E, F, D, none of it is outside it, right? Outside it, it's only C. But we are just done with one special substring. And if you're going to go for this too, so over here, yeah, there is something there. Okay, so it is not possible. How to do it? Anyone did this though? Like just to ask, just to clarify, anyone did this? Nope. Okay, let's go through it. Okay, see, now since we know that it has to be disjoint, and the most important part of every question whenever you are doing CP, the constants, n is lesser than equal to s dot length. I mean n is lesser than equal to 5 into 10 to the power 4, right? Not that much important over here. But k is lesser than equal to 26. Why? Because I mean k, okay, no, k is lesser than equal to 26. This is a very important concept. I mean very important constraint. And s contains only of lowercase English letters. Another important constraint. So in this case, we know that since s contains only of lowercase English letters, so it is very much evident that k should be lesser than equal to 26, right? So obviously, you can't have 27 disjoint substrings, whereas there are only 26 English alphabets in the letter system, right? English letters in the alphabet system, right? So in this case, what you have to consider is you are going to consider for every specific uh, letter in the English alphabet, that is from A, B, C till Z or Z, as you may call it. Okay, and you have to start from that specific position in the whole S thing. Okay, so let's say A occurs first over here. So from this position, you have to start checking till you find out that is a special substring. Is it clear? Like what you are going to do, why you are going to do it? If it is not clear, it's okay. Is it clear that what you are going to do? For A, you're going to do like this. For B, let's say it starts over here. So for B, you're going to go like this, and then this, till you find that it is a this substring is special. Okay, and for A, let's say if you're going like this till you find that this substring is special. Okay, example. Yeah, sure, I can come up with an example. Let's take this example only now. I think I explained the first two. So let me come up with this example, ABE, ABE. Okay, so that all of the examples are all of the test cases we are going through. Let's say it is ABE and ABE. Now see, for all the English alphabets, so let's say if I'm starting from A and I go on to consider all the substrings that starts from A, that is A, B. Is it a special substring? No, man. A and B, both of them are outside it. So we can't consider that. ABE, is it a special substring? Nope. ABE, all of them are outside it, right? So we can't consider it. Then we go for ABEA. Is it a special substring? Nope. Because there is B and E, which is outside it. So similarly, you can go on till end, and you can find that only when you go till the end, there is no substring in it. I mean, there is no specific character outside that substring, which is equal to the elements in the substring, right? So is this a special substring? Right? You will be like, yeah, it is a special substring. But it was also given that a special substring cannot be the entire string S. Okay, so this is not a special substring. This may feel like a special substring, but this is not. But if there was a F over here, in that case, will that be a special substring? Yes. In that case, it is a special substring. Okay, because there is a F over here, so it is not the entire string. Is it clear now? It is clear? Great. So for every specific element, once we are starting from it, so we can get the whole thing, whole segment. But the question is how we are going to do it. Very simple. How? So let's say if you're having two arrays, okay, or let's say two vectors of size 26 and BRR of size 26, or let's say 26 comma 0. What do I mean by 0? Okay, let me write 26 only, and over here I write into 0, which means all the elements are 0. Okay, so BRR can have the count of all the elements in the whole string. Okay, and then for every specific element, for from A till Z, or rather like it was smaller case, so from A till Z, for every specific element, what we can do is we can store, I mean for every specific element we can find out what is the first index of it. Okay, the first index. So let's say for A, in this previous case, I erased it. So in the first place that you find A, so let's say over here, from that case you're going to consider populating ARR, okay, and depopulating BRR. So what does ARR consist and what does BRR consist? ARR is frequency of elements inside. Okay, so frequency of element inside is ARR, and what is BRR? Of outside. Right? Clear? How we are doing that, I can show you the quickly go through the example once. I mean the code once. So for every specific element, what we are going to do is we are going to put that into ARR by making a plus plus and making and removing it from BRR, so making a minus minus, right? So at one specific position, when can we tell that it is a special substring? If all the elements in ARR is not there in BRR, right? What does it mean? That if for all the elements from 0 to 26, I mean from 1 to 26, no, yeah, from 0 to 26, rather 0 to 25, if all the elements that are in ARR but not in BRR, okay, that is if there is an element which is both in ARR and BRR, so we can say it's false, right? It is not a special substring, so we can directly say it's f equal to 1 and break. But if for every, after considering every specific element in ARR, we find that whichever element is there in ARR but it is not in BRR, and if all the elements that are in ARR is not in BRR, so it's a valid substring, and if it is not so, it's a invalid substring, right? Clear? Is it clear? Is it clear? Till now, is it clear or not? Slightly. What is not clear? Not confident. No, like you get the logic, right? You don't have to get the code. The code, I will explain it. Can you dry run on one example? Yeah, we can do it. We can do that. Let me just, but because like if you want the dry run, so I think I can go to the dry run at the end. I can explain the whole thing. Okay, I can explain the whole thing and then I'll just go through the code and then I'll just dry run it. Okay, for you to understand it better. Now see, you got the BRR AR thing, what it is going to do. So for every specific element, there will be 26. There will be 26, right? For every specific element, there are 26 elements. I mean, there's not 26. For every specific alphabet, there are 26 alphabets, right? And for every specific alphabet, we are going to traverse throughout the whole thing. That is big O N. So what is the whole complexity of the code? Big O N into 26, right? Which is well within our constraint, right? 5 into 10 to the power 4 into 26, well within our constraint. So this is a technique what we are going to do if we are going to make the whole thing. I don't know why this is not getting erased. Yeah. So this is the thing, like what we are going to do basically. Now let's say if we are going to get the segments, okay. So let's say for A, no, again I am doing for caps. So let's say for A, you got a segment, or rather let's say a segment of pair, that is it starts from position 1 and ends at position 2. For B, you find that it starts from position 3 and ends at position 7. For C, you find that it starts from position 5 and it ends at position 6, right? For D, or let's say there is no D, okay, there is only F and there is no other thing. So for F, it starts from position, let's say 10 and it ends at position 11, okay, clear? Now in this segments, we have to find what is, I mean, how many disjoint pairs are there, okay? What is disjoint? What do I mean by disjoint? So let's say if I put it on a number line, 1, 2, 3, 5, I am ignoring the elements that are not there, that is 4, I'm ignoring them, 5, 6, 7, then there is 10, and then there is 11, right? So A occurs, so I'll just use different colors. So for A, I'm going to use red. For B, I'm going to use blue. For C, I'm going to use orange. And for F I'm going to use black, right? So red occurs in 1, 2. Clear? Blue occurs in 3, 7, right? And C occurs in 5, 6. Okay? And F occurs in 10, 11. So from here, can you find out how many disjoint sets are over here? This is disjoint, this is disjoint. So I'll just, what color should I use? I'll use green now, okay? So this is disjoint, right? Well ahead. And from this two, this orange and blue, you can choose any one of that. Yeah, exactly, three. You can choose any one of it and then that will be disjoint. But you can't choose both of them. So in this case, if k is lesser than equal to 3, this will be a true. Do you get it? Why this disjoint thing is very important. Now we'll go through one example. Like you don't have to worry. I'll take, which example should I take? Clear. Crazy logic. Okay. Which example should I take? So I have one example which is very large, but obviously I won't take that. This is an example which is very large. Okay. But yeah, case 4 was GYYE. We can go with this example only, right? It goes well with our thing. Okay. See, A B C D B A E F A B. Okay. Let's say if you're, oh my god, if you're having, oh my god again. Now is it okay? I think now it is okay. Yeah. This much length will be okay. Yeah. See, if you're having initially the ARR, it will be, everything will be 0, right? And for BRR also everything will be 0. But this BRR can be like, yeah, understood. Right. Great. So for BRR, you know what? Like you can have the frequency of the elements. So A is present 1, 2. Okay, so you can just traverse over the whole thing and you can get it. So A is present twice, B is present thrice. Oh, sorry, A is present thrice. Sorry. A is present 1, 2, 3. B is present 1, 2, 3. C is present once. D is present once. E is present once. And F is present once. Right? Now what you can do is, so let's say we have to find, first of all, find what is the first position of A. That is over here. Right? Then this becomes 1 and this becomes 2. Okay? Then we go over here. Now, okay, first of all, when we are done with it, we are going to do a check. Okay? So you can see that on the first position only, both of them are greater than 0. So it's not the case, right? Because there is a A over here. If you're going to consider this, there's a A over here as well as there is a A over here and over here, right? So it's not a possible substring. So again, we go for B, right? So we make this 1 and we make this 2. The A is still not satisfied. The B is also not satisfied, right? Then we go to C. We make it 0, we make it 1. Okay, this 0. And we go on doing it. Okay. We go on doing it till the end. Like if you go through the whole thing, you have to go on doing it till the end. So what is A? A is going to be from 0 to, the segment of A is going to be from 0 to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9. Okay. So A is from 0 to 9. Clear? Similarly, what you can do is, you can check out for all the remaining elements also. 0 to 9. For B, it is going to be, if you start from here, I think it is also from 1 to 9, right? And even 1 to 9 won't satisfy, okay? 1 to 9 won't satisfy because there is a A before it. So B, you're going to not going to consider it only. Like if you go through the whole code, I will just print it out so that it will be better for you to understand. So what happens is, like if you go for B, you will have traversed throughout the whole thing and still it won't be satisfying, because BRR will be having a over here, and till the end also ARR will also have two A's. Okay, so it won't even satisfy after going throughout the whole thing. So for B we are not going to consider it. So for C, if you start from here and end over here, it is going to be there. Okay, so for C what happens, ARR consists of 1C and BRR consists of 0C. So yeah, both of them are not greater than 0, so it's a good condition, which means it is going to be 2 comma 2, right? For D it is going to be 3 comma 3. Okay, then there is a B again, A again, E, that means 3 4 5 6. So E is going to be 6 comma 6 and F is going to be 7 comma 7, right? Now if you go through what the code I have done for this, what I've done is I'm taking ARR BRR and I'm getting a segments for every one of them, and then I'm considering all the alphabets in the English letter, I mean all the letters in the English alphabet, and for every what I'm doing is basically I'm putting the value of ARR and BRR as 0. Okay, that is I'm going to initialize everything. After I've done with the initialization, I'm putting a flag over here which is not needed actually. I was trying just to do something else. And then I'm just putting the BRR as the whole content of the string. Okay, throughout the whole string, I'm going to increment BRR. And then I'm going to find the first position of A plus L. That is the first position of the specific alphabet that I'm at presently, specific letter that I'm at presently. And if I find that letter is not there in the whole string, so we can directly say continue. And if it is there, then start from that position and go till the end. ARR of plus plus, BRR minus minus, that is take the element from BRR and put it into ARR. Okay, and at all the positions check if ARR of j greater than 0 and BRR j greater than 0. So if both of them are greater than 0, at any case you can directly say that it's a false thing. But if for all the cases you find that ARR of j, if either of them doesn't satisfy, which means that there are elements in ARR, all the elements in ARR are not in BRR. Okay, so in that case we can directly say if f is equal to 0, we are going to push back into the segment first comma I, that is the position where it begins and the position where it ends, the special substring. And then this is flag equal to 1 also. I was explaining that it is like not necessary. I was somehow landed in Leetcode 1 out of 4 gang, somehow during the contest unable to think for optimal solution in specific. How should I practice? Okay, I'll just move on to that after I explain the whole thing. Okay, and then you are going to sort the whole segments, okay, based on the second element. Why we do that I'll explain you, and then I'm going to go through some algorithm. So okay, so why we do that? Okay, see, in the previous case when I was explaining you that you have to make a number line and go through to make the all the disjoint things, so what is the most greedy approach to check? The most greedy approach is check, sort it out on the basis of the last element. Okay, so what you can do is, so if you're, so let's say if you're having this, okay, so I'll just have a different color convention. So let's say if you're having like this and then like this, okay, then like this and then like this. Okay, so over here can you come out with how many substring? Oh, okay, no, I think I'll just put a different color for you to better understand it. Okay, so over here can you come up with the valid thing that what is the specific thing, substring that we have to consider, right, for the disjoint? So obviously it is noticeable from our point of view that there are three disjoint substrings, 1, 2 and 3, right? So we are not going to consider this blue, right? But if you are going to consider this, the number of disjoint substrings, you can notice one thing, that the next disjoint substring starts from a position way ahead of the end of the previous substring, right? So what you have to do is we have to sort it out, sort all the substrings based on the endpoints. Okay, so that is what we have done over here. Based on the second point in the segment, we are going to sort it out. And after that, we are going to check for every start and end. If, okay, there's one thing, if start is equal to 0 and end is equal to n minus 1, then we have to continue. Why is it so? Because this is for the condition that the substring is not the entire string S. So the substring can't start from the first position and end at the last position. So that is a wrong substring, okay? So in that case, we are not going to consider that. Apart from that, if we find that the start of the present substring is greater than the end of the previous substring, then it is a valid substring. That is, it is disjoint, okay? So we can write count plus plus. And now what happens? The previous end is going to be the new end, because when you go into the next element, now the previous element is the present element, right? That you were checking earlier. So previous end is equal to end, and at the end you can do a normal check. If count is greater than or equal to k, you can directly return true. Okay. Why we are doing it inside of the for loop? Because obviously once we get through that count is greater than or equal to k, we don't need to walk on it anymore, right? We can directly say, man, I'm satisfied with it, just return true. I don't need to check for the other segments over here. What do I mean by that? So let's say if we were given to find out that we have to check for only two, if there are two disjoint substrings or not. So once we are done with this green, okay, once we are done with this green, why would we even check the red one, right? Because we have satisfied it. So that is the reason. At any position, if count is greater than or equal to k, return true, and ultimately return count is greater than or equal to k. Okay, that is, if count is greater than or equal to k, then only we can say that it's a valid thing. Otherwise, it's false. Is the whole code clear now, along with the explanation that I made? Clear. Great, great, great. Okay, so let me just a minute, Amit. Okay. Uh, so what I will tell you that optimized solution. See, first of all, if you want to go for the optimized solution, you have to look into the constants. Okay, constants. Now, if you find that there is a constant which is so less, 26, so in that case, you know that you can consider that, and that won't be hampering you, because 26 is basically a constant, right? It is very close to a constant, so we can ignore that. So obviously, you can go for big O of k. Okay, big O of k. That is big O of 26. In this case, as I did. Okay. And for these things, so let's say if you're going to have only constants like 10 to the power 4, 10 to the power 5. So in that case, you know one thing, that if it's 10 to the power 5, it should be big O n log n. So the one of the n is going to be for the traversal and the log n is going to be for the binary search. Or sometimes it may be a little bit of different approach. That is, the log n is going to find the binary search using the lower bound and upper bound. Or maybe you're going to use a priority queue to get the largest element till now. So that log n you have to figure out, and usually the n is going to be for the traversal. And if it is greater than 10 to the power 5, so it means that it has to be big O n. You can't play with it, okay? And if it is very less, let's say 9, okay, if the constant is very less, let's say 9, 8, even 6, okay, 6, 5, somewhat like that. So in that case, you can surely say that it's a recursion, okay? So that's it, nothing else. Okay, so for each character in S, we are finding the smallest disjoint substring ranges with the help of the EMBR, then kind of doing line sweep to get, yeah, exactly. Number of non-intersecting ranges. Exactly. Is there any method to respond to this? No, not there. Yeah, exactly. This is a super chat thing. Okay, I can pay for myself. Great. Okay, so is it clear? Like, it is clear, right? Now this problem I haven't solved it yet, but I have a approach for it which you guys can go through, but still I'll just go through it, discuss once, okay, just to check if it is very simple or not. Because as far as I can think that there were more submissions for D, I guess, no, than C. And this is so surprising to see that how can people come up with solutions for a tougher problem than a easier problem. Initially I found that the submissions for D were greater than C. See, people have done, oh no, this is that guy. He does the previous elements, I mean the next, the most tough ones first, then goes to the easy ones. Oh, this is not that. This guy has done it, Harshit. Let's go through his code. Let me just explain the whole question till then. Okay, length of the longest V-shaped diagonal segment. Okay, I can't read the question. I don't have that much like patience. The second problem: how could I build approach using recursion to your solution? I had a sort of recursion. How could I build that intuition? The second problem: eat pizzas. Uh, See, what you can do is, if you want the recursion for this problem, okay, I'll uh, just remind me at the end of my this thing. Okay, just after I explain this, just remind me this. No, it's okay. It's okay. So length of the longest V-shaped diagonal segment. What do I mean by that? Let's say if you're having a grid, okay, so you have to start from a 1. So let's say there is a 1 and all the remaining elements are 0 and 2s, okay, 0 and 2. So what you can do is you can start from a specific position and then go into some direction, okay. So let's say you're going into this direction, and after you're done with that direction, or let's say in middle way, you can rotate 90 degrees, but it is going to be only once, okay. You can do it at most once. So you can go like this, okay. Or let's say if you're going like this, then you can go like this, okay. Or you can also go like this also, straight away, it doesn't matter. And like this also you can go, sorry, like this also you can go. Or what you can do is you can go like this also, or you can go like this and then have one of it, one collision. But you can't have more than one, that is you can't go like this, okay. It is not possible. So you can have only one. You can go like this and then this, or you can go like this and this, but not more than one. Okay, you get it what I mean. Now what you have to do is, there's a pattern that was given, okay. After the first one, you have to find the next two, then the next 0, then the 2, then 0, then 2, then 0, and you have to find the longest such sequence that you can find, okay. Now a very simple approach which I think will be giving you a TLE is to have a DFS thing, okay. Just go through a DFS, and in every specific DFS function, since you know that DFS is a recursion thing, so what you can do is you can memorize the whole thing. And after doing the DFS, so let's say if you're moving in this direction, which means +1 +1, okay. So there are 4 directions. One is 1 1, other one is 1 -1, other one is -1 1, and the other one is -1 -1. Okay, so 1 1 means like this direction. 1 -1 means the next part, then just below it, but towards the left. That is this one. This is 1 -1. And -1 1 is this. Okay, and -1 -1 is this. So you know the 4 directions, right? And you can change the direction only once. Okay, but you can't go from -1 -1 to 1 1, and you can't even change between these two. Okay, so you can, if you're at this any of these or any of these, you can interchange between them, okay, but you can't change inside of them. It is not possible. Clear? So using that, what you can do is you can have a DFS function, okay. The normal queries will be there, and there will be a direction that you are currently in, and number of changes of direction, okay. Number of direction change, how many times have you changed your direction. So this number of direction change should be uh, it should be lesser than equal to 1, okay. It should be lesser than equal to 1. Remember one thing. So that is one condition that you have to check. And yeah, one more argument I forgot, that is going to be the last position, the last element, okay? The last element that you came across. So if the last element is 1, it means that the current element has to be 0, right? Or is it so? I forgot. No, the current element has to be 2, right? It has to be 2. And if the last element was 0, the current element has to be 2 also. And if the last element was 2, it has to be 0. Okay, clear? So how you are going to do the DFS? But I haven't done it, but I think that it will be a TLE. Okay. So anyways, I'll just go through the discuss. Okay, so simple recursive solution, does it really work? Because someone just coded, I think, whatever I just explained. But I don't think it should work because the... Oh, okay. Now see one more thing about the constant thing that I was just explaining. N and M is 500, right? So if you are using simple recursion and memoizing it, okay, what is memoizing? Memoizing is, so let's say if you're having deep, let's say a Fibonacci, okay, a Fibonacci. So what is a Fibonacci? A Fibonacci basically means that Fibo of n is equal to Fibo of n minus 1 plus Fibo of n minus 2. Sorry, n minus 2, right? That is what Fibonacci series means. Okay, I think I forgot to go through it. Yeah, right? Fibonacci means that Fibo of n is equal to Fibo of n minus 1 plus Fibo of n minus 2. Now let's say for any position, I found out that this Fibo of n minus 2 has been already computed. Okay, so what I can do is I can store it in a DP thing. Okay, so that is about memoizing. I think he has done that only. We will start from a cell containing 1 and explore 4 directions diagonally as long as pattern is matched, and we are allowed to take one turn, right? Initially global array is d of I, d of j. Okay, notice that if we take a turn, direction increases by 1 cyclically. Right. What do we mean by that? I'll just tell you. See, what I told you, that you can go from here to here or here to here, right? Which means that both of them can't change. What he has come up with, that is, you can't change both of them. So from here to here, both of them change. That is, 1 becomes minus 1 and minus 1 becomes 1. So both of them changes. So it is not possible. It is only possible if any one changes. So if you're checking for this to this, 1 becomes minus 1. And if you're checking for this to this, so minus 1 becomes 1. So this is a better approach. Like this thing, it is very much hard coded, and what he has done, that is only one of it will be changing. So that is a better approach. If current index is out of bound, it returns 0. If current cell does not match the required pattern, it returns 0. If turn is not 0, which means we are allowed to take a turn, we will explore both possibilities of turn and no turn. Okay, and take the maximum of both, return it plus 1, because we know that current cell will be a part of the path. Okay, clear? If turn is 0, we will just keep moving on and same diagonal direction and call the function recursively. This is exactly the solution that I have provided you with. Okay, so d of j of 4 is minus 1 1 1 minus 1, and d of I of 4 is minus 1 minus 1 1 1. That is what I was explaining. Okay, 1 1 minus 1 minus 1 and 1 minus 1 minus 1 1. So he's just, what he's doing is, he's just, instead of putting it as instead of putting it as 4 separate pairs, he's putting it as 2 separate, like not pairs, 2 separate arrays of size 4. Okay, instead of having it as 4 into 2, he's having it 2 into 4, nothing more than that. then he is doing the simple thing. This is basically DFS only. Whatever he is doing is DFS only. Okay. So yeah, that's it. I think I won't be going through the code because yes, I obviously I haven't done it yet. But if you go through it, like you will get to understand that what he has done it. Okay, what he has done. It's a good one. Is it clear? Okay. In the second problem, how could I build approach using recursion to your solution? Initially, I had thought of recursion. How could I build that illusion? Okay. The second problem was this one, right? Eat elements. Okay, eat elements, right? W, X, Y, Z. Okay, so in this case, if you want to use recursion, it is very simple. What you can do is you can have a array called used. Okay, that's an array called used, which is of size n. Okay, in that case, what you can do is in recursion for every specific function. So let's say a recursion is a function, right? In that function, what you're going to provide is, I don't know why it is not tracing my write up. Yeah, see, used of n. Okay, you have to have a used of n, and for every function of recursion, you're going to return. I mean, the arguments are going to be used. Okay, one is the used, other will be the array itself. Okay, and nothing else. Okay, so at any position, if you find, so basically used is a boolean array. Okay, it is a boolean array which tells us whether we have used a specific element or not. So let's say if we have used the first four elements, okay, and the remaining are false, which means we have used the first four elements. So what is the condition? The base case is if all of used is true. Okay, that is we have used all the elements of used. I mean, we have used all the elements of pizzas. Okay, in that case, that's the base case. Return it. Return 0. Okay, return 0. So what we are going to return? Return 0. Okay, return 0. But otherwise, other than that, what you are going to consider? So whatever is having used as false. So let's say if there are x elements which is having used as false. So from those x element, you are going to take out 4 elements out of it. XC4. How can you do that? For all the elements, just take out any random 4 elements. Okay. And for all the possibilities, make these 4 elements as false. Make these 4 elements as true, and then find out like if it is a even. Okay, you also need one more thing, that is even or odd. Okay, even or odd, which is going to basically tell you that the specific day that you are at currently, is it even or is it odd. So if it is even, so you can find out the second largest element from this 4, and if it is odd, you can find out the first largest element, I mean the largest element, and then return that element. So let's say, okay, I'll just zoom it out. So let's say what you're going to return is that element, let's say it is y. Okay, that element plus function of the new thing. Okay, so if this was even, now it becomes odd, and if this was odd, it becomes even. Okay, and then you're going to have used ARR and even or odd. Clear? Is everything clear, Amit? You get it, like how we are going to do it if it was recursion? Well, now comes the last part of today's video, that is rating the problems. Easy, medium, hard. Okay, the first problem, what was the first problem? Find special substring of length k. So this was easy. Yeah, this was easy. Sorry, this was easy. B was eat. pizzas. So yeah, like it was a little bit of greedy, so I'll just rate it as somewhere medium. But the time complexity large, that I also can understand. I meant I cannot move to a solution through recursion, right? Oh, you meant, yeah, no, no, you can't move on. Like if it was recursion, that is the approach that I just mentioned. You have to do, but obviously you can't do that. Okay. B was medium. C was select K disjoint. This was like not hard. I won't say it was hard. It was somewhere between medium and hard. And D was also between medium and hard only. Okay. Just because of the time constant, I will just consider D as hard. But yeah, D was medium only. Just because of the time constant, I'm considering it. Okay. Actually, C was more of like putting the brain into, and D was more of algorithm. Okay. Rather, I will do one thing. I will put both of them as hard only. Okay. Works. D is hard because of the time constant, and C is hard because you had to put a lot of brain in it. Okay. So yeah, everything is clear for you guys. Is everything clear? And yeah, obviously I won't need to tell you people that to subscribe, because yeah, this is a subscriber only stream only. Like over here, if you are not a subscriber, you can't put the live sections. So what I am doing is currently is that I am putting only subscriber only chat, so that yeah, I need subscribers. Okay. Like I hope you get it. Like if you're making content and you don't get the subscriber, you don't get the motivation, so that's not worth it, right? So anyways, that's it from my side. Any other questions? Any other questions quickly? If there is no question, I'll just end the stream. There were 1111 drop frames, which means there was quite a lag in today's stream. Don't know, like I think it's because I haven't updated OBS. Okay, it's not because of my internet connection. For free, for three, I think I could build solution if I thought of brute force, but for two, it was not possible to form solution using brute force. Two is not brute force. Three is like, what was three? I forgot. Entire substring. Brute force, yeah. Like if you can get the ARR and BRR thing, you're good enough to go with. Okay, so that's it. That's it. Goodbye, guys. Take care. Radhe Radhe.